it's your 12.6 notes. We're going to be talking about the Pythagorean Theorem today, and it's our last section of the year. This is our last lesson. So thanks for watching it, and be ready to talk about it next time we have class. So Pythagorean Theorem is what we use to find the missing side of a right triangle. So we're going to do that, and then we're going to also determine if a triangle is a right triangle. So we're going to use all the information we learned about square roots and squares, and that's going to really help us with this. And this will get you ready for geometry next year. So a right triangle is a three-sided figure that has a right angle. You guessed it. So when you're looking at triangles, if you see a little box that has a right angle, then you know it's a right triangle. So for example, this is a three-sided figure. This right here would be a right angle. So this is a right triangle. So remember, a right angle means it's 90 degrees. So how do we find the missing side of a triangle? Well, we use the Pythagorean Theorem, which this is really important for you to remember. And next year, when you have Mr. Schwab in geometry, you're just going to totally blow his mind if you can remember this, because you're going to use this over and over in geometry. A squared plus b squared equals c squared. Now, what the heck does that mean? Well, on a triangle, this longest side is always called the hypotenuse. So I'm going to put this so you'll remember hypotenuse, this longest side, and this is always considered C. Now, A and B are the legs of the triangle. It doesn't matter which one is which. I like to make the shortest one A and then this one B. But you can go back and forth with those. It doesn't matter. But that that C is always across from the right angle, the hypotenuse, and it's always the longest side. So what we're going to do is we're going to find, in these problems, they're telling us that A is 9, B is 12, and they want us to figure out what C is. So if it helps you, you can draw a little right triangle. So this would be 9, this would be 12, and they want you to, they want you to find this side. So we're going to do that by finding this Pythagorean Theorem and plugging in our numbers. So A squared, so I'm going to do 9 squared plus B squared, and that's going to equal C squared. So we're going to figure out what these are. So now that you guys are pros with your squares, 81 plus 144 is going to equal C squared. And then we solve that, we get 225 equals C squared. And remember from our quadratics that you're going to get rid of this 2, this squared, by square rooting both sides. So square root of 225, that means C is equal to 15. So this section, this is why it's really important to remember those perfect squares. It's going to make your life so much easier. All right, let's try this one. So we have our triangle. If you need to draw it, you can. So A is 6, C is 14, and we don't know what B is. So this one's going to be a little different. So we have 6 squared plus, I don't know what B is, so B squared equals 14 squared. So we have 36 plus B squared equals 196. Now this one's a little different because B squared is right in the middle of the equation. So remember, solving equations, we're going to minus 36 on both sides to get that B squared by itself. So this cancels out. So B squared, equals 160. And then our final step usually is to do the square root of both sides, get rid of that square, but 160 isn't a perfect square. So sometimes this might happen, and you just have to use your simplifying radicals, where you're going to find the biggest perfect square you can divide by 160. So I'm going to do this in a different color. So sometimes your last step is simplifying a radical. So the biggest perfect square I can divide by 160 would be 16. So 16 times 10 So that's perfect. It's going to come out. So 4 and 10. All right? So this one was challenging. You had to get b by itself and you had to simplify a radical. This is the most challenging you'll ever see. So go ahead and circle that one and we'll talk about it a little bit more in class. All right, this one I'd like you to try on your own, please, before you get to class. And then this one, I'm going to get you started and I'd like you to try that too. So notice that this would be the right angle. So this would be C. So I'm going to write C here. This is the little shortest side. I'm going to always make that A. And this would be another leg, so this is B. So go ahead and set up your Pythagorean theorem knowing what these are. Sometimes you're going to have to do that. So go ahead and try example 4 as well before you get to class. All right, last thing we have to do is figure out if they give me 3 lengths of a side, you have to determine, is this a right triangle? So if we have 5, 7, and 9, the biggest side obviously has to be C. So 9 has to be C. So I'm going to make this A and this B. Now, if it's a right triangle, the Pythagorean theorem will work. So this should be true if it's a right triangle. 5 squared plus 7 squared should equal 9 squared. So 25 plus 49 equals 81. Does it? So let's ask ourselves, 25 plus 49, well, that would give us 74. So that doesn't equal 81. So what that means is this is not a right triangle. Oops, no, not. Okay, so why don't you guys try this one as well? So you guys have a little bit to do. If you feel like you know this well enough, then we can just talk about these in class, but it would be good practice to try 3, 4, and 6. All right, thank you so much for watching, guys. We'll talk about it next time we're in class. See you later.